Hello YouTube viewers, welcome to my show Future Friday. In today's episode, we're gonna talk about Robonauts. So let's dive right into it. Well, first, before we understand Robonaut, we have to understand why the heck we need Robonauts when we have astronauts. So, well, first you have to understand humans are very limited creature. Even if, let's say, you made the magical suit that I was talking about in my last video, where you literally feed it 1 or 2 liters of water and it can keep going for 24 hours. No problem with that. But that human still has limitations. Let's say, first of all, let's say you pooped and your stomach is clean, you still can only work for a few hours without needing a break, where you have to eat again. So you have to understand that like we really need breaks again and again and again. And let's say by some magic you have like glucose feeding in you directly, again it's a very gross kind of situation, because like that's okay for a patient, but it's not something that you're gonna as a natural normal working human. On top of that, let's say you figured all of those out and somehow your spacesuit can even take care of the poop aspect. You still have to understand that humans needs to sleep. So let's say you have an astronaut or something like that, you can't keep working 24 into 7 into 365. So we are limited. So especially if you want to construct anything in space, that is a very serious limitation. And you can see that in construction when we do on Earth, we have shifts of people, like sometimes 2 shifts, sometimes 3 shifts, sometimes even as high as 4 shifts. So humans are limited. So that is the first reason why we are working and trying to get robonauts. On top of that, space is very dangerous. Now again, if you're watching my channel, there is a very good chance you understand that, but you have to grasp that concept. Like when you are inside a space station, there is at least let's just say, instead of 1 inch of armor, you have 1 foot of armor protecting you. So there is some chance that you can survive if anything bad happens. In space, there is no protection for you, so it is very dangerous inherently, and you do not want to lose human astronauts. A, they are very expensive, and B, they are human. You do not want to lose humans. So we need help with work, and we do lot of quote unquote work, like actual construction work. So we need it. It's not something like, okay, build a Burj Khalifa with one person. It can't be done. So why Robonaut instead of if you're familiar with International Space Station, you already know it has Dexter, it already has a Canada arm and all that. So why do we need quote unquote a Robonaut? Well, all this jazz that we are doing, everything in space, be it Curiosity, be it rovers and all that, be it Voyager, all of that is just to provide us knowledge to send a human there. That is the end game. We are not gonna be like if tomorrow somebody comes out, it's like, yeah, we're never gonna leave this planet again. All the space program will end up like a flat out done. Nobody's gonna invest in it. So we are doing that. Again, it's just a very slow process. It might take 1 century or 3 centuries. Who knows for how long it takes before it's something that human can quote unquote say colonize. But we are doing it for that purpose. It's like, okay, we are building ISS. Why? So people can live inside it. So we can understand what are the pros and what are the cons of it. So you can understand everything, every entire NASA, entire ESA, entire ISRO, whatever have you, they are only there for human benefit. So humans are the core component of that. Now, because humans are doing everything here, every tool that you see, every switch, every knob, every handle, every lever that you see is designed for human. Basically, human hand can a human hand grab it? Can a human hand move it? So that is why you have like giant levers on doors. So you don't have tiny lever. Again, a robot may have enough strength to do that, but a human will not have that. And like outside of International Space Station, you can see this quite clearly. Canada arm is very versatile, but it cannot grab on anything. Like it cannot just go itself and weld it automatically. So it has ports. Basically, it has a specific place where it can clamp and then do whatever it needs to do. So any designer who's designing something like this, let's say ISS, they have to design the whole station in such a way that 2 people can use it. Basically, a robot which has robotic arms, robotic appendage, power requirements and all that, and another a human. So that is why we want to bypass that. It's like, instead of designing a structure that can accommodate 2 who has, just accommodate 1 person. That is the whole idea. And on top of that, let's say we build robonauts and all that, and they are not very smart or powerful and all that, but it will still turbocharge humans' ability. Basically, you have 1 person and he can guide, let's say, 4 or 5, 6 people, or he may be there is some tricky thing that requires you seeing, checking, analyzing and all that, but it requires you to precisely hold. That is very critical aspect, because weight is not an issue, but you still have to precisely hold something. Let's say, okay, there is 2 clamps that have to mesh, but you have to double check everything. So you have 1 person holding it. Here's the deal: have humans. Humans are generally muscle bound creature. Muscles are not designed to be like It's not gonna do it. It's gonna vibrate over time. And again, when you're in 0G, even like the reason why cameramen generally have a big rig, because it slows down the weight. 0G, you don't have that. So even a kilogram object or 10 kilogram object will start to shake. So you want to use Romanauts in those scenarios. So not only it will simplify the design, because everything, every door, every lever, every drill, everything would be designed for one purpose. It's like, hey, can a human use it? Awesome. Robot can also use it. It will also turbocharge humans that we already have in space. So that is another add-on. Now, what are our current options? Well, NASA already knew about this, and they have been working for a very long time on this. But the early attempts, like practical attempts, was made in around 2012 and all that. And these Robonaut 1 and Robonaut 2 have been sent to space. So it's not something that somebody is working on a lab. It has been to space. Now, it has done through space testing, and there are a few interesting things we learned about it, like how the size affects the astronaut, because you have to know that the whole place is quite cramped. So somebody has to think about the size, shape, and the whole reason this robot is so interesting is because it's a compliant robot. I have provided a very interesting live demo of this robot, and you can check it out. It's designed in such a way, even though let's say it's holding 10 kilograms, and you bump into it, it's not gonna hold its arm as as a rigid metal object. It's gonna give. It has a bit of flex, so it is not deadly for human. That is a very critical aspect with robotics. Like we have robots, building our cars and building our buildings. So we have that. It's just if a human get caught in there, the robot is gonna be like, if robot action is lift 1 ton and move 1 ton and then drop it, it's gonna do that. It does not care whether there is a human. It's gonna be like whoosh. So you have to understand, we don't want astronaut to be whoosh. So this structure is designed to be 100% human safe. So if it detects human, it stops, and it has multiple ways of ensuring that. So even if software failure happens, it's not gonna be like the accident, saw in space. It's not gonna do that. So this is our current option. Now, what can we do to that? Like, what can we upgrade? Again, NASA had sent it to space and they have brought it down. And I have also provided a video where you can see the current iteration that has been worked on right now. So basically, the Robonaut right now, the first generation and second generation, they were basically inside the ISS. Basically, they were made for human atmosphere. So that's awesome and all good, but they have to design it in such a way that it can work outside of ISS. Now, you may think, wouldn't that be very easy? Well, yes and no. Yes, if they are only designing it to work in space, that's quite easy. They have to design every bearing and all that. But if you are designing something that can handle let's say temperature management, temperature fluctuation of space, it generally ends up becoming very bulky, like spacesuit. That is why you don't wear spacesuit inside the space station. So they have to design it while being compact, while being that it can withstand both of them without extra effort. That is a very critical thing, to design something that it can handle atmosphere pressure and vacuum. So it is tricky, and not to mention thermal management, all that, and not to mention in vacuum metals have a tendency to automatically weld if you bring them together. So it is kind of tricky to make it what we call space ready. Is very tricky. Now it can be done. Again, we have Canada and we have other robots in space that have been going on for 40 years, so we know it can be done. It's just how to do it more efficiently, more effectively, with having this many joints and complexities. So that is one major challenge, how to design it so it can just go instead of going through airlock, it will just have a dock. It's like you just flush it out of the ISS. So that is first requirement. Second, we have to make it modular. Right now it's already modular because they are built in two core parts. Part number one is basically upper torso. Why upper torso? Well, that's the astronauts working end. Basically astronauts legs are generally locked. Basically it's locked on a grip or something like that, so their legs never move, because they are floating away in space, so they don't need their legs. So leg is just there as a clamping point, and the human hands are doing the most of it, and hands are the most complicated who are in human body. Basically ask any robotic engineer designing elbow, that's not too difficult. Design shoulders, okay, now it's bit more flexible. Design hands is like, I'm out, because you have to understand, this is very complex. And on top of that, even though these are this tiny, they are very powerful for their size. The reason was that our muscles are here, not here in the fingers, they are here. That is why you have all the tendrils and all that. So it is very tricky to do. For our given space to weight ratio, it's quite awesome. So that is why the scientists were focused on only this part, because as long as they can attach it to a shaft or anything like that, it's gonna do the work. Now, on top of that, there is another benefit. Again, you can mount it onto a Canada arm, or you can mount it to some creepy looking legs. These look very creepy. This just look wrong. But again, it does that work it's supposed to do. It's supposed to allow the basically Robonaut to crawl on ISS same way an astronaut does, rather than requiring robotic arm. So that is why it has to be modular, where you can just change parts depending on what you need. Now, what we can expect in the future? Now, this is a very serious aspect that you have to understand. It's a necessary add-on. Now, could we survive in space without this? Well, yes. Can we thrive in space without this? Well, not so much. Again, it is an option. It is available to humans, so we have to explore it. Think of it this way. Let's say you are in lunar surface, and you're like, okay, I built a basically giant colony. Yes, the colony will require a lot of maintenance, and if you ever slack off on the maintenance, it could kill people. Now, the same goes with machine shops. This is one thing that people learned in a very hard way. Nobody likes to do maintenance, flat out. Nobody likes to do maintenance. So there were very large machines like lathe, milling machines, and all that. Those are awesome. Here's the deal: they require you to lubricate them, every once in a while, whatever their time may be. Like, hey, you used it for 100 hours, please, lubricate it with oil. Nobody used to do that. Their machines used to prematurely die. Somebody finally gave up, and it's like, okay, here's an automatic system. Just make sure that tank is full. Even people stop doing that also. So now their tanks are you just plug it once in a year. Just make sure you double check the oil level. So you can understand that humans don't like repetitive tasks. Robots, they are built for that. They are specifically designed for that. So let's say you have a lunar colony and somebody has to go around and double checking it. You need to do it fast. You don't want to use legs for that. Wheels. Now let's say there are some places in lunar which is very rocky, so you can't walk on it, nor you can use wheels. Crawler. So you get the idea. Like, we want to build it as versatile as a human, rather than a human getting on a suit, putting exoskeleton, or going into a rover. Ta-da! So it is very expanding. Like, it will turbocharge how many humans you have there. Let's say you can only send 5 humans. Let's say only 5 humans agreed for your crazy risk of building lunar base. 5 humans plus, let's say, 10 Robonauts or 100 Robonauts, you can do amazing things. Basically, you can literally make again, you can't build practically speaking another Robonaut because PCBs are very hard to build, but you can do a lot of things. Like, you can do a lot of things in like just a few people guiding these things without latency and lag, and they can do amazing things. So it is a quite bright future for Robonauts in the future. So this was my presentation on Robonauts. I hope you liked it, learned from it. In that case, please click a like button. If you didn't like it, didn't enjoy it, I'd urge you to press dislike, press it twice to show me your respondent, and please leave a comment because I reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.